In this video, I will review the problems that were presented as examples in the reading summary so that you can check your work.
So for example 1, you're just asked to determine if a permutation or a combination would best describe the situation. You're not asked to actually do the calculation just to say which one should be used for the given circumstance. And so for this first one, there are 3 security positions available at a hospital. There are 12 candidates who applied for the position. And how many ways could the positions be filled? So this one here, I mean, they're just security positions. They're not any specific titles beyond that. So me saying that, John, Jake, and Joe or security got the job, got the 3 positions, or Joe, Jake, and John got the job, it doesn't really matter which order that we say that they got the same positions. So it's a combination. The order does not matter in this one. For the next one, the sponsors of a local essay contest received 35 essays from students. The prizes for $100 for the best essay, $50 for the second place essay, and $20 for the third place essay. How many different prize award outcomes are there for this situation? Now this one here, I mean, since it does matter, there's 3 people being chosen out of 35, but those 3 are going to have specific rewards. So if I say, like, Kate got $100 and John got 50, it's different than me saying John got $100 and Kate got 50, and not mentioning the $20 person at all. So, the order does matter here, so it's more of a permutation. The next one, there are 10 candidates for 3 positions at Johnny Rockets. 1 position is for a cook, second position is for a food server, and the third position is for a cashier. If all 10 candidates are equally qualified for the 3 positions, then how many different ways can the 3 positions be filled? So again, the order matters here because someone being hired to be a cook versus being hired to be a cashier is totally different. Don't necessarily know how realistic the situation is, but this would be a permutation because the position that's being filled by a certain person, it could be different, and that's a reason why it's a permutation. During a special promotion at Dell, a customer purchasing a computer and a printer is given a choice of 2 free software packages. If there are 9 different software packages from which to select, how many different ways can the 2 packages be selected? Now here, I mean, I'm just choosing 2 packages, and it's really unrealistic for me to pick the same thing twice. Like, I want Microsoft Office twice, it doesn't really, I can only install it once. I mean, so now this is more of a combination because it doesn't really matter which order they were chosen or which order they're given to me. I just got them both, so that's all that matters for that. Jimmy has 7 CDs and wants to select 4 to take with him to work. How many ways can he select 4 of the 7 CDs? Again, if he chooses, I mean, whatever 4 titles he gets, I mean, it doesn't matter which order they were chosen. The order doesn't matter in which they're chosen, so it is a combination. So now this problem here kind of goes through like the difference between permutation calculations and combination calculations. Let me show the first 2 in contrast with each other. As you can see here, the permutation, which we looked at before, of 9 and 4, it's just me starting with 9 and having 4 integers to multiply. So I start with 9 and go down each, until I get to 4 in total. Not the number 4, but 4 total integers. So 9 times 8 times 7 times 6. The combination is the same thing on top, except I'm going to divide by this numbered factorial, whatever that number is. So 4 times 3 times 2 times 1, that's why it's 126. So this one here, I'm going to have 6 times 5 on top, and I'm going to have 2 times 1 on the bottom. And that gives me 15. Here I'm going to have 6 times 5, and that's it. That's 30. The permutation of a 12p5 is going to be 12 times 11 times 10 times 9 times 8. Those are 5 numbers. Multiply them together. I get 95,040. The same thing, I'm going to have the same part of this with the combination. I'm going to take this number, though, and divide it by 5 factorial, which is 5 times 4 times 3 times 2 times 1, which gives me 792. An ice cream parlor has 20 different flavors. Cynthia orders a banana split and selects 3 different flavors. How many different selections are possible? Um, so for this one here, no order that the flavors must be in. I mean, it's just having chocolate, vanilla, and strawberry and having them in a different order doesn't really matter. It's the same flavors. So that's the first thing. So we have 20 different flavors. She chooses 3 different. It is 3 different flavors. So they make sure it is 3 different. There's no repeats going on here. She isn't going like chocolate, strawberry, chocolate, something like that. That would be a totally different situation and require a totally different calculation. So we have 20 to choose from. 3 are being selected. And so I'm going to have 20 times 19 times 18 on top over 3 times 2 times 1 on the bottom. And that's 6840 over 6, which comes out to be 1,140. For test questions on an English test, Tito must write an essay for 3 of the 5 questions in Part 1 and 4 of the 6 questions in Part 2 in any order. And that's the part that kind of already tells you it's going to be a combination. In any order, it doesn't really matter. How many different combinations of questions can he answer? So the number of items is going to be the number of items from Part 1 and the number of items from Part 2. So, how many different ways can they be answered? I'm going to take the number of ways, the number of different possibilities from Part 1 times the number of possibilities from Part 2. So for Part 1, he has choose 3 out of 5 questions. Now it's a combination, and the order doesn't matter which they're answered, so it's going to be 5C3. And the second part is going to be 4 out of 6. It's going to be 6C4. This is going to be 5 times 4 times 3 over 3 times 2 times 1. This is going to be 6 times 5 times 4 times 3 over 4 times 3 times 2 times 1. Just kind of knowing how to set up the formulas. And when we work this all out, like it's 10 times 15, which is 150. So there's 150 different ways that he can answer these questions on the, for the test. So, forming a committee. The Philadelphia City Council is forming a committee to explore ways to improve public transportation in the city. The committee will consist of 4 representatives from the City Council and 3 representatives from a Citizens Advisory Board. If there are 7 City Council members and 5 Citizen Advisory Board members from which to choose, how many different ways can the committee be formed? Now, again, in each case here, I mean, the committee members on this, Public Transportation Improvement Committee, it doesn't matter which order they're going to be chosen. So there's no particular order here. So the number of possible committees is going to be the number from the City Council and from the Citizens Advisory Board. So it's going to be the number that I could get from the City Council, a number of different combinations there, times the number of Citizen Advisory Board combinations. So there's 7 City Council members, 4 of which are going to be chosen. So it's going to be 7C4. And I'm going to choose 3 representatives from the Citizens Advisory Board, of which there's 5. So it's going to be 5C3. And of course, this is what they equal, which gives me 35 times 10, which is 350 different ways the committee can be formed.
And that is the end of this video. If you have any further questions, please make sure to reach out and ask me about it. Until next time, have a good day.